Well, hello, everyone, and thank you for joining us for this special episode 4 of the Urban Passive House series. My name is Zach Semke, and I'm director of Passive House Accelerator, and we're really excited to be partnering with New York Passive House on this series. To the heart of the program today, we're super excited to have BKSK here to present about Charlotte of the Upper West Side. It's a gorgeous project, and I can't wait to dive into the details with them. Again, we're so happy to be co-producing this Urban Passive House series with New York Passive House. And with that, I'd like to hand it off to Amy Fiala, who will kick things off.
Hi, everyone. Welcome to today's episode. My name is Amy Fiala, and I'm from BKSK Architects, and I'm also a board member of New York Passive House. We're really honored to be here today to co-host this presentation. And for those of you who are not familiar with New York Passive House, our mission is to serve as the New York hub of Passive House through collaborative advocacy, policy initiatives, education, and resources. And we welcome any and all membership and involvement. You don't have to be an architect to or an engineer to collaborate with us, and we welcome all of you to join. So with that, I'd like to just say a little bit about the questions and answers at the end. Please feel free to enter your questions in the chat throughout the presentation. We will keep track of them, and then we'll ask them at the end in the order that they came through. And we'll call upon you to ask your question if you're still with us. So with that, I'd like to introduce William Russell and Todd Poisson from BKSK, who will be presenting today. William Russell joined BKSK in 2015 and was promoted to associate in 2019. He's worked on several of BKSK's most ambitious and institutional, commercial, and multifamily residential projects. And his design expertise is essential in projects which call for a strong understanding of sustainable design strategies. And his most recent project, in addition to Charlotte, is 470 Columbus Avenue, which achieved Passive House low energy certification. And we would also like to introduce Todd Poisson. He's an exemplary leader of complex teams, and his current work is mainly comprised of ground-up buildings in New York City. Particularly notable are the Jefferson and the Citizen Manhattan condominiums, as well as 529 Broadway, a 6-story retail building in Soho, the cast iron district, whose facade reflects its context with a gradient from the punched windows of one of the historic neighbors to the expansive glazing of the next. And we're really happy to have both of you here today to talk about Charlotte, which is just a really beautiful project. And with that, I will let you guys take it away.
Thanks, Amy. It's great to be here.
Yeah, thanks so much.
Let's dive in. I'm gonna do just a quick introduction to the project. I'm really gonna let Will do the lion's share of this presentation. I'm gonna set up just the introduction and the design approach. But first, as Amy started to describe, BKSK does a lot of work in landmark districts. And this is a great example of bringing Passive House to a landmark district. It's one of the first that we know of, first new buildings, first new residential condo, new building, Passive House certified in a landmark district in Manhattan, in the Upper West Side historic district of Manhattan. So the district, our client likes to point out that this district only has a handful of new buildings that have been approved regardless of their status or type in the last 30 years. So super proud of this building. Let's dive in. We have a long history to our firm. I'm a second generation partner, but we have over 200 built projects, and we're really proud to have this one under our belt, being a Passive House certified project in this district. It joins our 80+ landmarks approvals. in the city. Next. So a quick background to the project. We are located at 470 Columbus Avenue, which is in Manhattan in the Upper West Side, Central Park West Historic District. We're between West 82nd and West 83rd Street on the west side of that block. So being on the short side of an avenue block, you are allowed certain massings that you're not allowed on a side street, and that led to our kind of L-shaped building, which is relevant to today's discussion, as will point out the plan opportunities that it provided for the Passive House service to the plans. That's us, that's our site, existing site. In the middle there, it was a pre-existing 3-story commercial building. And as the designation report stated, that Columbus Avenue was largely built up with flats and tenements, with commercial storefronts. And importantly for our argument to landmarks, or the main thing the hurdle to go over, was this stretch of Columbus Avenue especially is characterized by 5-story tenement buildings. There's a gap to our left there. Our site was always 50 feet wide. It was never a 25-foot wide tenement. So it did allude to its otherness, but we really had to convince them that what we were removing here was not as contributing to the district as what we were proposing. Next, we looked all throughout the district. The Upper West Side is just rife with just beautiful, beautiful brickwork and terracotta work. A lot of recessed planes and grids of masonry, we called it. Especially that lower right is the Lucerne Hotel on 79th Street. Just really spent a lot of time studying its really beautiful velveteen brick and deeply, deeply raked terracotta masonry laid up on that facade. And that really inspired us to create a facade that was worthy of the district, that contributed to this district, and lent itself to the Passive House ideals that Will describe. So this was our interpretation of the district. This is our rendering that was approved by landmarks and is remarkably accurate to the built condition. We're super proud of our construction partners at Hudson Meridian Construction. They just did a terrific job in building this. You'll see photographs in a second that really look quite like this. But will describe this facade construction with this terracotta shade system, terracotta louver infrastructure that is independent of the enclosure of the building. The idea in our landmarks approach was to present a facade that from the outside was very contextual with its tenement building fenestration pattern. In other words, a smaller punched opening windows in the neighboring masonry buildings were kind of reminiscent to the clear space through our terracotta screen. But on the inside, and really one of our clients' desires was to have a very, very contemporary interior. In other words, virtually floor to ceiling glass in these apartments. There are full floor apartments. So each floor you see there is a living space with the kitchen to the right and open to the living room to the left. So 50-foot wide living space with, as will also describe, unencumbered by mechanical soffits because of the attributes of the Passive House facade. Next. So standing on the sidewalk, looking up, and these are both renderings. The idea was just to be kind of camouflaged into the context with smaller apertures, but from the inside, you really appreciate the floor to ceiling glass, and you get to see your facade from the inside out, which is like is just a terrific opportunity here. On the left is the approved rendering seen from the south, looking northwest. Ironically, the only mechanical things you see in this rendering are the neighbors' chimneys that we had to extend as part of the code. Part of the Passive House benefits are that small rooftop mechanical footprint, which will in fact convince our client to pursue Passive House because the rooftop scope would be diminished and thus sellable as residential terrace. Next is photography. So finished photography, kind of the same views, not instead of looking from the south, but looking from the north towards the southwest on the left there. And that same image kind of looking up from the sidewalk, just very reflective of the proposed renderings. We are fully approved and signed off at Landmarks, as well as the building department. So this has received its notice of compliance from the Landmarks Preservation Commission. They share our happiness with this building. We really feel it's a triumph for this district, for this deeply detailed terracotta and brick facade. Next, I think that might be it for me, Will. I think, let's see what's next. Yeah, just some final details. The one on the left looks remarkably like that rendering earlier, showing the corbelling at the 5th floor that relates to the 5-story datum line of Columbus Avenue. We corbelled the brick to acknowledge that datum and then extended 2 more floors, changing the color of the terracotta infill and the color of the terracotta louvers as it extends 2 more stories. So it's a 7-story street wall. And then there's a duplex apartment that's hidden behind above the 7th floor street wall, disguised by that heroic cornice. We called it the visor, but we were inspired by the grand cornices of the Upper West Side and use it as a device to, in fact, disguise a setback duplex apartment. And that's some storefront detailing on the right. And I will let Will take it away.
Yeah, so I just wanted to touch on a number of topics that came up during the development of the project and as it evolved through the development and into construction. First, talking about the terracotta sunshade louvers, we'll go into detail about that. The roofscape, which was its own little project, how we handled air distribution, the ERV system, kitchen exhaust, the ever pesky trash chutes and passive houses in New York, and finally, our lessons learned with the air tightness testing and detailing. So terracotta sunshade louvers. As you see, this is the view from the interior. So in terms of how we thought about developing it, when thinking about how to develop a project that's contextual to this district, as Todd noted, that it's predominantly punched masonry facades. So you could do something like this, right? But it doesn't meet some of our clients' goals with wanting to capture the views and bring in a lot of light to the interior. It also, as you can see here in this light diagram, doesn't distribute light very evenly throughout the space. So if we were to say, okay, well, let's give the client and the marketing team their dream building and do floor to ceiling glass, obviously it's not very contextual in the district. You also end up with major glare spots this is the great room on the right-hand side of the plan here, with dining, living, and kitchen all in one 20-foot wide by 50-foot long space. So we started studying, some of the context of the facades immediately adjacent to us and throughout the district, looking at multicolored masonry, how those pieces are interwoven, sills and lintels into these beautiful brick and terracotta facades. So breaking that down and starting to look at the patterns that masonry inherently gives you with these 3 courses, came up with this interwoven terracotta louver sunshade system has 2 different colors that switch on and off at the lintels and sills. And they act as sunshades in front of the louvers, and then they actually thread through the brick piers and get laid up with the bricks in those piers. So this is the final result, in that you get a reading of a punch masonry facade, but from the interior, you get clear views out. And here's that heat map of sun penetrating into the interior. Here's a study of those 3 options that we looked at in developing the project. Punch masonry facade, you get very little direct sun in. All glass facade, you get really too much. And then on the final result, it's, you don't get a lot of sun and glare coming in, but you get a lot of nicely distributed light. And because we're fortunately on the Manhattan grid on the west side of Columbus, we're actually oriented this facade isn't due east, it's actually slightly southeast. So it works well for summer shading while still letting some sun in during the winter to heat the space. And actually, we did a test in the PHPP. Without the sunshade, our space cooling demand is above the allowable 17. And with the sunshade, we're below and pass. It does raise the heating demand, having the sunshade louvers, but after we developed it, we actually went in and found windows that were even exceeding what this calculation shows for U values, and made up our heating demand actually came down quite a bit with those new products. And then, so here's the built product, looking very much like those initial sun study renderings, with sun penetrating the interior as it would punched masonry facade, but you're able to look out and see the beautiful city beyond, and you get this nice lighting effect, like a light shelf bouncing sun up to the ceiling and distributing more evenly throughout the space. From the sidewalk, especially looking at that raked angle up, it looks very much like a punched masonry facade. And then, after it was built, you start to notice other things that are fun, like at night or at dusk, you start seeing the glow of the light coming out and really animating the facade. And then that's the final build photo. And then to dive in a little bit on the detailing of that sunshade system. So we knew a few things. We knew everything had to be thermally broken, obviously. We also knew that putting this system in front of a window, this window is not just any window. We knew it would have to be a super high performing window, probably getting shipped from Europe. Any sort of attachment to that, if we relied on any sort of attachment to that window, would just really complicate it, the two systems. So we designed them to be totally separated so they can be installed independently. And the terracotta is actually suspended on a post that's hung from the slab above and hung much like a curtain wall with just lateral pins below and brackets that cantilever off of that post and hold the extruded terracotta baguettes. So this is like a structural diagram of those posts on the left.
Well, people are asking what window system. I believe it was Zola.
Yeah, Zola. And we used the Thermoclad Plus and their ZNC line, the extra high performing ones for some of the larger windows, or to meet the comfort criteria. So here's that post system with the cantilevered brackets and the extruded terracotta that you see from your living room window looking out of the building.
The terracotta is from Sannini, from Italy, and they engineered this infrastructure with us. They really partnered with us hand in glove. It's a really beautiful system to see from inside your residence.
Yeah, and this is a great shot too. We did a lot of research and actually flew out there to their shop in Italy because we wanted to give the terracotta a sort of iron spot look, much like a lot of the historic brick in the area and the brick that we're using elsewhere in the facade. So there was a lot of research and design on how to achieve that. And they even had to build their own mechanism for distributing these, I think it was magnesium sort of pigment onto the clay before it's fired to get that effect. There are those baguettes in process at the facility in Italy as they're drying. This is the array of different shapes that we use on the project. So, the terracotta baguette, elliptical shape. We have a number of flat profiles we used on the panel on the wall. And we even have some, which you see here, which are toothed to be laid up in the masonry of the brick. So it's laid up with mortar. And here's a shot of those different pieces all together. Okay, so just moving quickly here, we want to talk about the roofscape because this was really one of the generators for wanting to do passive house on this project. One of the benefits of working in this landmarks district is if you can get a building approved that's this tall, you're one of the tallest buildings around, and you have really amazing views all around. However, because we were limited on height and views from the street of what you could see, any bulk that's up on the roof really couldn't be seen from the street. And we also couldn't bring an elevator up to this floor. So there's a kind of quirk in the New York City building code that if you're not considering it a story, i.e. you don't have an elevator to it, you're limited to 33.33% of the roof can be this bulkhead. So literally every square foot that we can save for mechanical equipment is another square foot of sellable penthouse area. So at $3,000 a square foot, you can do the math, it adds up pretty quickly. So working with our mechanical engineer, using the Passive House, the PHPP, and looking at the loads in each unit, we were able to use these fairly small sort of quote unquote suitcase condensers rather than large boxy condensers. And those can get stacked vertically and really minimize the mechanical enclosure here. Looking at it, if it wasn't Passive House, it would probably be twice that big, maybe another 200 square feet. So that's 200 square feet that can be added into this glassed in penthouse volume. Here's a diagram of that. So essentially anything that's dark gray counts toward that 33%. So these small boxes here represent all of the heating and cooling equipment for the entire building. And that story kind of got woven into the marketing of the project and how we developed renderings. And it's become, something that everybody is very excited about, that you can occupy that terrace, you can walk all around it, plant it, and get these amazing views out to the city. Okay, and then just to dive into some of the details about air distribution. Like all of our projects, we try to keep things, fairly minimal, clean, and soffit-less if possible. So right off the bat, the mechanical engineer did the plan on the right with showing a line of diffusers, a third of the way into this great room of the living and dining. So we said, no, we're doing Passive House. We don't need to bring the air diffusion right so close to the windows. When we gathered all the data with the NFRC ratings of a U value of only 0.15, therm analysis of that window showing that even when it's 14 degrees outside, it's still 66 degrees on the interior surface. And we convinced them that actually you can bring all the diffusers in this great room and all the bedrooms all the way to the most inner wall. So essentially all these rooms, these are 3 bedrooms. This is the primary suite. This is the great room here. There's no soffits in any of them. The ceiling is just the skim-coated concrete of the slab above, and all the air is distributed through 1-inch slots into the room. And so you can't use the same ducts, right, for your fresh air supply as your VRF supply, but we were able to put them very close together and use the same linear slot diffuser so that in the final product, you look up and it's just a very clean, thin line on each of the walls. Going into the ERV system design. So this project, it's essentially 1 apartment per floor. Each apartment is a full floor. So, and we, unlike a lot of our projects where you're maxing out height, you're maxing out FAR because we're limited, because for our landmarks approval, we wanted to just save as much space as possible. I think on a typical project, we probably would have put the ERV in its own little closet, and you can deduct that closet from your area, your zoning area, and you go on. Here, to take up a 3-foot by 3-foot closet for this ERV is 9 square feet of lost usable area. So we integrated it into a compartment up in the top of the primary closet. So here's what it looks like when it's installed. And then for the showroom, we worked with Henry Built to build out these built-in closets, and you can hardly even tell it's there. It's disguised between the panels above on the top here. And because each unit is its own, it takes up an entire floor, and each unit gets its own ERV, there's no air shared between apartments, which, since this was developed during the height of the pandemic, that was a great selling point for everyone. And you get this sort of fun pattern on the courtyard side of the building of the intake and exhaust for the ERVs. It wasn't so fun. I'll address this in the air sealing topic, but because when you do your final blower door test, you want to close off of these vents. Because there was no way to access those, we actually had to cut open the ceiling and seal them off from the inside. So that's something to think about down the line. the kitchen exhaust. So one of the things that a lot of times we talk about this project as a passive house without compromise. And one of those things that we didn't want to compromise on, talking to the broker team and our owner, is kitchen exhaust to the exterior and gas cooking appliances. A lot of our projects, low energy projects, we try to push induction cooking and recirculating hoods, but that just wasn't an option for this type of project. So we have 900 CFM kitchen exhaust. So basically almost like commercial level cooking kitchen exhaust for each kitchen. And it's handled in a pretty complicated system where there's essentially what you see here. This is your exhaust above the cooktop going out, and this is your makeup air coming in to meet the passive house requirement of always balancing the air. So each of those has a mechanical damper, and then the intake, the supply air, has a VAV box that ties in to your hood, so it can sense what the airflow is that you're sucking out of the building, and it lets that same amount of air into the building into a nicely disguised diffuser up against the window here, which you can see in the ceiling of this picture. And then this is the gas range and the 900 CFM hood above it concealed into the cabinetry. So very, high performing system, but if you didn't know what you're looking at, you'd almost not even notice. Yes, so the trash chute door, I think a lot of people working on multifamily projects in New York are familiar with this issue. It's essentially, by code, you're required to have a big 2-foot diameter hole going out of your building. So the way that's often dealt with is, the trash chute, the access to it on each floor is in a trash room, and you seal that room off almost like it's an exterior door, an exterior room. Because this project, each apartment is it's the full floor, there's no trash room. The trash is actually accessed via a hatch in your kitchen, which is very convenient, but it makes sealing that chute a bit more difficult. So we came up with this system, which is essentially like an exterior level door with weather stripping all around, that with specialty hinges and a panel from our kitchen supplier attached to it, blends seamlessly into the kitchen around it. So these are the plan and section details of that with the weather stripping. And here's a picture of it in action. So if you didn't know what you're looking for, just really the lever gives it away. This is the door that you open to get into the trash chute in your kitchen, and then you just open that hatch. So during our blower door tests, this performed pretty well. There was a little bit of leakage, but really not so much. Same with the kitchen exhaust. That was a concern with the mechanized dampers, that those might be leaking air when it's pressurized. But it all actually was pretty tightly sealed, but we did have a few other problems, which I'll address. So yes, talking about airtightness and airtightness testing. So this project, we wanted to test it as it was built, before the walls were closed up, to see how we were doing. Because for pretty much everybody on the project, the contractors and most of the consultants, this was their first project that was Passive House. So that's our Passive House consultant on the left, Jordan Goldman, setting up the blower door test. This is the contractor, the site supervisor here. The issue with doing this in a tall building in New York is often you have a hoist that's bringing materials up to every floor with a huge, like 10-foot by 10-foot opening to get materials in and out of the hoist. And that stays in the project until pretty late. Usually it's, there even as you're putting finishing materials in. So that overlaps with when you would want to be doing all of your sealing for air tightness. So what we did is we basically blocked off that hoist into its own room and sealed it off. First, they tried doing it with plastic and duct tape, and that did not work very well. Just the pressure of the blower door eventually pulls it off. So they ended up creating a lot of temporary walls throughout the project. So that at least gave us enough to pressurize the building. At first, we weren't even able to pressurize it to see where things were leaking. So that we got enough pressure, we could start using the smoke wand to go around and see where we're having leaks. The one major culprit was, these windows, they were shipped from Europe and installed, and they were not installed with the hardware fully intact yet. So they weren't getting a tight lock, a tight seal. So as you see here, a lot of air is coming in. So once we got that fixed, we moved on to the next thing, which is all of the interior walls, particularly any CMU, where there's CMU throughout the building as the backup wall to the masonry facade. So that needed to be sealed and sealed well, particularly at lot lines against our adjacent buildings where you're not able to even access the exterior for your air and water barrier. You're relying on this essentially paints on the interior face of the CMU. And then there's some spots like here between the edge of the stair that was already cast in place and the CMU that they built, that it was difficult to get in there. There's only an inch gap that they can get in there to put the air barrier. But once we got that, once they resolved that, that pretty much took care of the leaks through the CMU wall. The details that you see here for our windows, we kind of jumped through a lot of hoops to minimize any sort of soffit, but to still include things like a shade pocket. So you'll see there's the concrete slab, there's the CMU backup wall with lintel, and then there's a metal extension so that you can hide the shade pocket all within that thickness and not have to bump out the wall much. So every time you have that change of material, we were finding leaks, but when you change between stud framing to the CMU, the deflection track between the CMU and the slab above, you detail it with the continuous air barrier, but in the end, there's always little corners that they miss. So that's what you see here on the right, just different, just finding little tiny cracks that really add up. This is the topic I touched on earlier where, for the final blower door test, you want to seal off these ERV intake and exhaust louvers, but there's just no way to get back there. It's in the courtyard. To bring in scaffolding to get up there would just be a major hurdle. So it was actually easier for them to cut open the ceiling and seal it from the interior and then patch it up when it was done. So with all of that, we were starting to get very, very tight. However, so sorry, one thing just touching on, I'm sure other people that are working on passive house experience this, when you're counting on any sort of interior insulation, it's often ripped out by electricians or other trades and not put back in the, best manner. So that's something we had to keep on top of. But for air sealing, one of our major issues that for future projects we'll make sure to think about this differently is the passive house envelope for the building was just the residential portion. So the upper floors and this residential lobby on the ground floor. All of the retail space was outside of the envelope. So, we didn't consider that part of the passive house. It wasn't triple pane glazing or passive house glazing. And there's a lot of louvers for the air inlets to those spaces. So what we found after we were able to seal everything, this is one of the last pieces of the project to go in. So this was always just like a big hole until pretty late in the project. So after they got this installed and we were able to do the blower door test, we found just a ton of leaks through the storefront system, through the louvers, through all the framing around. And also these retail spaces are connected to the residences above through numerous shafts that go down through the ground floor and into the cellar. And there's a stair that goes down into the cellar, which then connects, to the rest of the building. So in the end, that was sort of our downfall in being able to meet the 0.6 air changes per hour for the Passive House Classics certification. We ended up meeting just 0.88 air changes per hour, which is still an excellent building and qualifies us for Passive House low energy. But for future projects, we'll make sure to specify a system there that can get very well air sealed. So like one of the best champions for this project was our client in doing Passive House, and it's all these measures we're talking about found their way into even the marking material that you'll see on the website if you want to go peruse. They do these great little animations explaining to sort of the layperson like how ERVs work and the ideas that triple pane glazing and the acoustic benefits of that and the differences in sun angles from summer to winter and how that's all thought of and used in the terracotta facade. So I think it was a really successful project, and we're like this close to actually getting the certification. I think we're just waiting on our certifier to wrap up that review. And that's it. I think anybody wants to ask questions.
Well, while we wait for questions, we should point out too that the owner during construction, as Will pointed out, was during COVID, and our owner thought of adding UV light to the air supply too. So there's UVC energy in all the supply air duct work in everyone's apartment too, and their two apartments are occupied, and the reports of the air quality. And when we visit the building too, it's just so uplifting when you walk into these apartments. They're just that the air feels like the beach. It's just super clean, and there's reports of flowers living for months and months and not having to be changed out or thrown away. So we're really hopeful for this combination of technology for the future.
Thank you so much, Todd and Will. That was great. We do have a lot of questions, and we will just take a quick break to hear from our sponsors. So everyone, please stand by.
Hi, I want to take a moment to thank the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, BKSK Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewizo, Gradient Comfort, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And thanks to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Innotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Thank you very much. And then also, I just want to say a quick thank you to our New York Passive House sponsors. Our gold sponsor is Rockwell, and our silver sponsors are BKSK Architects, the Durst Organization, and KSK Construction Group. And thank you also to our bronze sponsors. So we can move to the questions. We have a lot of great questions coming up. Get to our list here. So first on the list, we have Noah Reimers made a comment about the terracotta fins. Noah, do you want to ask a question?
Yeah, thank you guys for the presentation. Will, you mostly answered what I had said. I would love to hear more, excuse me, hear more about just the potential, sales. It looks like from online, at least, the sales have gone well. I would just love to hear more, and you touched on a little bit with the marketing material, but how people who have no idea what Passive House is or understand some of the technology, kind of their reaction to things. It seems like some of the marketing has done a good job of explaining that, and just hear a little bit more about people's reaction.
Yeah, I think if you look at the website, they sort of put it all into a larger bucket for sort of like health, wellness, and efficiency. So they really emphasize a lot of the health benefits of having, say, the ERV recirculating and filtering the air, the comfort that you get from having these nice substantial windows that stay warm in the winter and also provide acoustic benefits. But I think, yeah, and I think for some people, the energy efficiency is going to be an interest. But I think in terms of how they are marketing it to the public, it's really mostly about the wellness benefits of Passive House.
Clean air in this era during construction of the project, for better or for worse, clean air became a buzzword. And then lately in the last few weeks with the smoke from the Canadian fires as well. So it seems to be as Will said, a good sales point is clean air. It's always demonstrably marketable at that point.
And sustainability in general, I should mention, like every wood, all the wood you see in the entire project is FSC certified, and there's like basically no VOC products used.
Thank you.
Great, thank you, Noah. The next question was from Stuart, and it was actually answered in the chat. But from Harry from BKSK. I don't know if Stuart, if you want to hop in, and if Harry would like to hop in as well.
I thought the answer, this is the problem that real estate developers have, is the assumption that there's a cost premium. And Harry's answer was that the cost premium was encountered due to something else, which was going to result in higher square footage at the property, which was going to result in higher volume of sale dollars. And that's what it has to sing. And I was really happy that was the answer that came up.
Mm-hmm. But there's no denying that there was a hard cost increase. Like the interior, there's a ventilation system that's not required with other ways to build buildings. So our owner did double down, and he really was committed to this. So there is a lot of costs of it. The facade design, though, was probably separated. That was a design approach that lent itself to both Passive House and to the owner's desires, but really the landmarks district, really, all those variables led to that facade design. And it's still, our office policy for years now has been 3 or 4 inches of exterior insulation, and this building is no different. It has 4 inches of exterior insulation. It's just well taped, and the membranes are there. They're inspected more than maybe they otherwise be. But as we all know, the New York Energy Code is one of the most aggressive in the country now, and is leading closer and closer to Passive House. So this was a great experience to get kind of ahead of the curve in both sales, marketing, and design of this type of building, which we'll see more and more of.
There's a second question which is related to this, which is related to cost, which is, do you feel that because of the superior quality of the thermal envelope, you're able to downsize the HVAC equipment?
Yeah, significantly, and we'll show that in the kind of the rooftop diagrams. And it was one of the initial arguments for Passive House that the owner really grabbed onto, because every square foot of free roof terrace space is sellable as a private terrace in this instance.
Yeah, again, that's the real song. Wonderful.
And just to interject a little, Todd and Will had told us in the practice round a little bit about how the owner came to be convinced about Passive House. Do you want to just talk about that for a second?
Sure. Yeah. Well, yeah, we were walking to a landmark staff meeting at the very beginning of the project, talking about the building and how great the rooftop would be, and how much we could get approved for up there based on sight lines. And I just brought up that if we went to Passive House, we could drastically reduce the mechanical size on the roof, and every square foot of that could be turned into penthouse space. So that kind of got the hook, and then he just became very interested in Passive House in general, and it worked its way into the marketing and just the whole ethos of the project.
Yeah, and the layouts of the fact that they wanted 1 apartment per floor, and given the L-shaped building type, given its location, zoning wise, we're allowed to do that, and it just lent itself really well to the location of that central ventilator for every apartment. Just kind of the things fell into place relatively easily for this to keep the owner interested.
That's fabulous. And you said that the owner is now like very committed to the effort as well, and is super has become a big fan.
Yeah, he would love to
really
have been
great.
here. He sends his regrets. It's we should name him. It's John Rowe Corporation. They've just done a terrific job here. There was also a question on who would the mechanical engineers. It was GEA, David Glickman's operation. Before we forget, we should credit them for partnering with us on this.
Great, thank you so much. The next question up we have is from Herman. Herman, would you like to ask your question?
Sure. Todd and William, great presentation, by the way. I got a ton of questions, but I will try to reach out to you guys. I don't want to take up everyone's time, but the first question I have is, as far as your analysis on your windows, what software would you use?
Yeah, the what I showed in the presentation, that's actually from Zola. They had already done it as for their passive house certification.
Okay.
So yeah, if we were doing some more customized window that hadn't been tested yet, we would have needed to do that. And usually it's Therm. That's the
You would use
software. Yeah.
Okay. The next question is for your trash chutes. Your detail that you showed. Is it possible that I could even look at that detail at another date or something?
Sure. I can bring it back up on the screen. You can do a screenshot if you want.
Okay. Yeah.
Oh, there you go.
Okay. Yeah, I'll definitely take a screenshot. Thank you.
The hardest part about this detail was getting the owner to be okay with seeing the lever. It was, because you have to have like a positive latch on the door to really get these seals to work. Everybody wanted it to just be, no hardware, you don't see it at all, but we ended up with that. And I think it actually is for the best, because that door is going to get used a lot, when people put the trash in there. So
And it's a beautiful lever.
it's a beautiful lever. Yeah.
Thank you so much.
Thank you, Herman. Up next, we had Michael Constantine, but I believe his question was answered. He asked who the MEP engineer was. And Michael, did we answer your question, or do you have any other on that? If he's still here.
You got it. Thank you.
Okay, thank you. Up next, we have Kazuko. If I'm saying that right?
And that's great. It's Kazuko. And
Kazuko.
I just love this presentation. It's so inspiring. So thank you, everybody. And my question was the air distribution. I mean, it was so beautiful that there's no clunkiness at all. It's so streamlined and it's so incorporated into the design. Can you share a little bit about what manufacturers you used and how this design evolved to be so efficient and low profile? It's just stunning to me.
Okay. Yeah, I mean, for the heating and cooling, that's a VRF system with overhead fan coil units, which is kind of standard for any of our condo projects. So you get a condenser on the roof and then the fan coil in the space. There's 1, 2, 3 units that get ducted and concealed in the ceiling and then distribute air into the room. What you don't see on here is there's in the hallway, there's a number of slots for the return air to go up into the fan coil. So that's pretty standard. That even on non-passive houses, we use that. I think the trick was the ERV for the fresh air and exhaust, bringing that in and coordinating it to end up right next to the fan coil distribution, so that you don't have like one louver for fan coil, one louver for ERV. It all is composed on each wall. We looked at the elevation of each wall and really try to compose it with the sprinklers and just keep everything on that back wall so nothing pops out into the space.
On this, William, I think you said it before, but can you remind us how you had to do makeup air for the kitchen hoods, right? And where is that coming from again?
So there's a large rooftop unit on the very top of the bulkhead that's tucked back and out of view from that you don't even see unless you're really up on the bulkhead. So that, you know, when you turn on your fan, your hood to 900 CFM, you have to bring 900 CFM into the space, which is a lot of air. So that's why this unit is so large, because it has to provide that 900 CFM really times, not quite times 7 units, but you know, there's a sort of calculation that goes into that if not, hopefully not everybody's using their fan at 900 CFM at the same time, but it has to heat and cool all of that air. So it comes in at the ambient air temperature and without a bunch of humidity in the summer. So the rooftop unit that heats and cools the air and brings it into the space and drops it down next to the windows here. We tried to find the space, you know, the spot in the plan that you're least likely to be standing at. So these kind of, it's a pretty broad diffuser to allow the air to kind of fan out and not really, so you don't feel it coming in.
That 900 CFM number probably strikes many of you as being kind of large. You know, that's just an example of this client's desire to have no compromise, he didn't want any question unanswered or answered by, you know, oh, we didn't do that, and potential buyers came through. So the best of everything, you know, open gas flame, you know, somewhat unusual for passive house, and that 900 CFM exhaust hood. So really pushing the envelope. Thank
you. And Costco, I don't know if we've answered all of your questions, but you had asked about the type or the brand, I think, as well.
For the rooftop unit or for the ERV? The rooftop unit is sort of, it's just like a standard rooftop unit that maybe you'd have for like a gym or something. I think it was maybe Green Heck. The ERV is the Zender, I think it's Q600. Mm-hmm. And what's nice about that is that you can integrate it with an app on your mobile phone. And if you want, you can put it into boost mode. If you're having a party or something, to, you know, you just swipe it on the app and, you know, you're getting double the fresh air in your space.
Great. And then the heating and cooling.
Heating and cooling, the VRF system, I think it was Mitsubishi.
Thank you. Okay, so up next we have Lindsay Klein.
Hi, the most beautiful project, and I live nearby. I just can't tell you how fabulous it is in the neighborhood. That's a beautiful piece of architecture.
Thank you.
I just wondered what was preventing you from including the retail spaces in a passive house envelope?
Yeah, good question. I think cost was the main one at the start. Just this, you'll see here, like the glazing is actually comes out at an acute angle to sort of be reminiscent of the sort of shop front, storefront design of historic buildings in that district. So it's a pretty customized system. So to then do that in a triple pane passive house level glazing system would just cost a lot extra.
I thought you were going to say that maybe it was just too much solar gain, you know, because of retail windows.
Well, yeah, that plays into, yeah. So you would have to, you know, purchase a window with all the criteria to make sure there wasn't too much solar gain and there was a high U, you know, good U value, and so that's the thinking there. Also, part of it is just the complexity. You know, these storefronts, you know, a lot of times the building is signed off and it's a TCO, and these aren't occupied yet because they're still for sale. So and they need, oftentimes if they're going to be leased out to a retail tenant, they're going to need to get customized. So there was an idea that if it was all like stringent onto the passive house certification, like that may restrict what future tenants could do. Each space actually does though have an ERV, which is not typical. That was just our client felt that if the rest of the building is getting heat recovery ventilation, then the retail spaces should too. So
yeah, I mean, I do think that it does speak to the quality of the building. And I was just intrigued that you had said you had such a lot of difficulty because of the blower air testing and the air leakage. If you had your druthers, would you have included it?
no, I mean, I don't think necessarily, sure, but if we don't, that's not our money.
No, but I mean,
but I think what we would have done is like addressed it early on, and how we can specify systems and stuff that, although they're not passive house, are, for sure airtight, and everything is constructed and detailed in such a way that they're tight. I think it wasn't, it was a surprise to us that it was so poorly performing, because I think it was Schuko. It was a Schuko system that for the glazing, just decent glazing system, but in the end, there was just a lot of gaps. I think a lot of it was where the glazing meets the louvers. It's just very complex. There's steel supports running across there. There's a lot of little corners that need air sealing, and it's just very difficult to get in there.
Thanks.
Great, thank you. We did miss one question. Heather had asked if this was PHI or FIAS. I think you answered it before.
Yeah, PHI certification. Yeah.
Great. All right, up next we have May. May, would you like to go forward?
Sure. Thank you for the amazing presentation. The project was very beautifully designed, and I'm sure it has been beautifully coordinated as well. I have a general sense of how much coordination would have to go in for this type of project. The work of BKSK have always inspired me. I do have a question on whether there was a preference between a UPVC window versus the wood frame that was selected for the project, because I had thought that I would typically see sort of like an outboard insulation sort of coming to overlap the sill a little. Maybe we could go to like the window details or so. Yeah, because this is a wood frame window. Yeah. Was there like could this just simply be switched to a UPVC and it would work the same?
Yeah, I think as long as the U values were comparable, that would work. I think we were really just enamored with the finish of the wood. There's these beautiful French oak wood floors, and then we kind of came up with a custom stain to the pine frames on these windows to blend with that. So it just felt like, being in all the wood is FSC, so it just felt like very like a really nice direction. But I don't think there's any reason you couldn't use UHPC.
Yeah, now that I'm looking at this
PVC
for a longer period of time, I see that the insulation does come up on the windowsill on the outside.
Yes, there's a bit of
block it up, and then the steel in, and then so there's no significant bridge there. I do have another question. When the previous participant asked about the software that was used for the Therm, which was the Therm software, I then just recall that what about the daylighting software that you use? What was that software?
That was somebody else in our office that did that. It was a Honeybee, I think, that they used.
Okay, the plugin for Grasshopper.
Yeah, exactly.
Rhino. Mm-hmm. Thank you.
Mm-hmm.
Great, thank you, May, for those questions. Those are great. Noah, we have another one from you. Go ahead.
Just curious if you guys had considered any type of active solar shading in lieu of the existing passive terracotta baguettes.
I think the original. Oh, go on, Will.
I mean, active in that every window has a roller blind on the interior, so that provides some level of shading. Mm-hmm.
Okay.
Yeah, and I was just going to say that the idea of a masonry facade and an active and deeply raked facade just was one of the original kind of conceptions and inceptions for the facade. So we were wanting to block out stuff from the thermal energy from the get-go.
Sure.
Great, thank you. Oleg, you're up next.
Thank you. It's really incredibly looking building. So congratulations, guys.
Thank you.
A couple things. Have you, as an option for Zender, did you use a CO2 detectors to, to include in the system? So when it's CO2 gets too much, then it's automatically kind of increase the CFM on a ERV unit?
Yeah, I know that is an option with that new series, the Q600. I don't know if it did get programmed in to do that. I think we're just more focused on, it's running continuously at sort of a mid-range level. And then what was really important to us is that the user be able to control it and put it into boost mode when they want.
I see. Okay. All right. Thank you. I have another kind of maybe a little bit a plug. There is I see how you not struggle, but what kind of a problem you have with airtight testing. There is a new product, actually, the Coltraco Ultrasonics, that really allows you to spot the air leaks in a building. So it's just like,
okay,
maybe in the future to use that, it's really kind of a helpful instrument. Instead of using a smoke stick, that one really kind of helps to pinpoint with great high accuracy to where it is. Yeah.
Okay. Oleg, can you type that into the chat? I didn't catch the name there.
Oh, okay. Yes, I will. Yes, I'll try.
Thank you.
I actually just added it to the chat. There's
oh, you did?
the URL.
Okay.
Yep.
All right. Thank you.
Thank you.
Great, thank you for that. And up next we have Eric. Eric, are you still here? If not, I can read the question. Are there any additional liability issues for ice buildup on sunshade above the public sidewalk, even though it is a rare event it could happen, I guess? Yeah.
Right, good question. Part of the thinking behind that sort of rough surface that you saw on the terracotta baguette, that also happens to look a bit like iron spotting, is that it does help retain the ice so it doesn't build up, and then the sun shines, say on like a metal louver, melts the surface of the louver and then it all comes off at once. It's designed to sort of grab onto the ice and melt slowly if any ice does build up.
And they are inclined. They're all sloped.
Yeah.
Very interesting. Wow. Thank you. And then up next we have Miguel. If you're still here. I'm going to read it then. So he asked, why did you go with PHI? It seems like the site climate data driven certification of FIA might have been advantageous. It could be a tough one to answer, but
yeah, it's a tough one. And like, it feels like every time I dive into it, there's differences, like, everything gets updated. I think for us, it's changing a little bit, but I think when this project first started, we were looking at Passive House in early 2015. PHI still seemed like, it's the international German standard. And our client felt like that even could play into the marketing, that it's the original, it's no compromise. It's, our floors are French oak and our Passive House is German standard. So.
All right, thank you for that. And then this is going to be the last question today, but Sabrina asked if I could read, how was the direct hot water
like the domestic hot water. Yeah.
Excuse me, domestic
That's just
hot water. Yeah,
those are just gas boilers in the basement, in the cellar.
great. Thank you very much, everyone, for your great questions. And thank you to Todd and William again for this wonderful presentation. It's really a beautiful project, and I can't wait to go see it in person. And thank you, everyone, for joining. Zach, do you have anything else?
Well, yeah, I mean, just thanks so much. I think I was sharing before the show today that across my LinkedIn feed came the familiar trope about Passive House being ugly. And not only is this work a very compelling counterpoint to that, but it also goes further and demonstrates how you can harness Passive House and the lower energy loads of Passive House to be able to create really gracious, bigger, to carve out more space inside that's beautiful and livable and great to be in, as well as outside. And the terrace, the terrace example is, I think, with the requirement of less equipment up there, kind of opened up new possibilities that otherwise wouldn't have been there. So really great stuff. Thank you so much for the work that you do and for presenting it to all of us.
Thanks for having us.
Yeah, thank you so much for hosting these events. They're so great.